Hey guys, uh, we're doing another project video. Yay! Everyone was excited for that, right? What is this? The third one I'm making? Okay, so this one is probably gonna be a bit complicated compared to the other ones. So I'll try my best to explain, about this. So let's begin. So this is the graph I went with. It represents a real world function that shows how students' ACT English test score, which is basically the output, depends on their scale score, which is the input. It helps us understand how performance on the test translates into a standardized score. So let's talk about the inputs and outputs. So, like I said, the input is the scale score a student receives on the ACT English section, and then the outputs is the English score, which represents the raw or interpreted performance on the test. This function measures student performance on the English section of the ACT. It shows how the number of correct answers match to a standardized score. So this is the table for the graph. As you can see, it's mostly increasing, mostly by twos, but there's some that go like by threes, but or add by threes. So yeah. So before I talk about the key features, here are a few statements that I want you guys to answer. It's literally part of the agenda. I'm not even kidding. It's part of the thing for this project. So, yeah, here they are. So the first statement is the English score increases as the scale score increases. Then, the next statement is the graph has a decreasing interval between scale scores 10 and 12. And then the last statement is the graph represents a function because each scale score has exactly one English score. So you can pause the video or for a few seconds, or I'll wait for a few seconds or whatever, to answer these statements to see if they're true or false. So yeah, I'll give you some time. Okay, so it's now time to see if your answers were correct. So let's begin. If you say true for the first statement, then that's correct because the graph is increasing. The score, all the scores are increasing. Duh, there's no decrease. If you say false for the second statement, then that's correct because obviously there's nothing decreasing. So yeah, of course it's gonna be false. If you say true for the last statement, then you're correct because yeah, each score has an exact score, like each exact number. So yeah, that makes it true. So let's now cover the key features. The x and y intercept support 0, 0 because that's literally the only numbers that have 0 as the x or y coordinate. That could also be set for the minimum, that it's 0, 0 as well because that's literally the smallest number it can go for. As for the maximum, there is no maximum because as you can see in this graph, the graph is just infinitely going up. There's literally no limit at all. So yeah, there is no maximum. As for the domain and range, it's 0 to infinity because obviously all the x and y values are going to keep increasing forever. There's no end. So yeah. Also, I drew that because there's literally no infinite symbol. So I have to draw the notation. So for the intervals of increase, that's 0 to infinity because obviously the graph, once again, the graph is increasing over time. There's no end. So yeah. And then there is no intervals of decrease because no point in the graph is it decreasing. So yeah, there's none. As for if this is a function, it is because every x input has an exact y output. There's like no repeated x values at all or any repeated y values. So yeah, it is a function. Lastly, for the key features, the graph is continuous because obviously, yeah, the graph is infinitely going up. Infinitely, there's no end. So yeah, it's continuous. Now for the last part of the video, so basically what I noticed, what surprised me, and one thing I want to learn more about. One major pattern I noticed is that the graph consistently increases. As the scale score goes up, the English score also goes up. However, the increase is not always by the same amount. Sometimes the English score jumps by 2 or 3 points, and other times it only increases by 1. This tells me that the relationship is increasing, but it's not perfectly linear, as you can probably tell. What surprised me the most was how a small increase in the scale score can lead to a large jump in the English score, especially at the higher end. For example, going from a scale score of 15 to 16 boosts the English score from 29 to 32. A big jump for just one scale score. And one thing I want to learn more about is how ACT scale scores are actually calculated. Are they based just on how many questions you get right, or do they depend on how other students do too? Understanding the scoring process would help me better interpret what each point on the graph really means. So, thanks for watching this video. I put my best effort into this. I really hope I get a good grade on this because I want to end algebra with 1 to 2. Yeah, 1 2 on a on a bang, a higher note. So yeah, thanks for watching. I really want to get to 100 subscribers. I'm really close. So yeah, please subscribe. So yeah, thanks for watching.